The next 10 years will be decisive to avoid catastrophic climate change effects. More than 3/4 of the planet's land surface is impacted by human activity, and therefore it is more important than ever to raise awareness of current, past, and future land characteristics and dynamics. To do that, FAO has developed EarthMap, a web-based tool to improve access to environmental and climatic insights. But first, we need to speak about data. There are petabytes of climatic, Earth observation, and natural resources data freely available to scientists and experts. Institutions such as NASA, the European Space Agency, or JAXA, and many others are opening up their archives of satellite imagery, climatic, and other data they gather, allowing anyone to download and use them. Heaps of open data are now added to these archives on a daily basis. There is a problem, though. Too much data can be difficult to make sense of when your computer's memory and processing power is limited. Thanks to the rise of cloud computing, the storage, processing, and visualization of the data is no longer an obstacle, allowing users to focus on the outcome of their analysis. One of the main actors that has increased our ability to use this data has been Google Earth Engine, a cloud-based platform which lets scientists, NGOs, and non-profit organizations use the processing power and storage availability on their servers in order to advance science and our understanding of climate change. Google Earth Engine provides a way to manipulate this data that requires expert knowledge of programming languages, thus making analysis challenging for non-experts that might want to get insights from their vast archive but do not have the possibility to learn how to use it. EarthMap bridges this gap, allowing access to a set of environmental and climatic analysis through Google Earth Engine without the need for coding. The tool is accessible to anyone with an internet connection and does not require registration. Its interface has been designed with the user in mind, allowing an easy access to the most commonly needed types of analysis. The user can select an area of interest at national, subnational, or custom level, and can then proceed to visualize maps on different themes, as well as generate statistics for those specific areas. Amongst the over 100 analyses possible through EarthMap, the user could obtain land cover data for a project site, including the changes of land cover through time. The user could also generate a yearly trend of precipitation for a continent, watershed, or district. Or, for example, generate a table with monthly temperature data from 1979 onwards that could be used as a basis for a policy decision. The analysis is done on the fly by Google Earth Engine, so the user can draw a polygon or upload the boundaries of a project in order to get information specifically for that area. This tool has been used mostly for project design, monitoring, and evaluation. It can be used anytime climatic and natural resources insights are needed, anywhere in the world. In EarthMap, the user starts by selecting an area of interest, which could be a country, region, or continent. The user is then presented with a list of themes, and within those themes, a layer can be visualized. In this case, within the forestry theme, we have the global forest change layer, where tree cover and tree cover loss can be seen in Paraguay. We identify a lot of tree cover loss in orange and red. Once the user clicks on the country, in the right frame, we can see a list of the possible zonal statistic analysis that can be performed. One of them is to obtain land use areas from the CCI land cover dataset. Here we see how the forest in 1995 was 24 million hectares, while in 2018 it is 17. The user can also analyze the land use transitions. Here we see again how between 1992 and 2018 there was a 24% forest area loss, and also visualize the transitions between forest to grassland or cropland. Next, we see how the boundaries of a specific project can be used, in this case a pivot irrigation project in Egypt. Using the Landsat imagery, we can observe the project even if there is no recent very high-resolution imagery available. The vegetation index zonal statistics can also be used to understand when this pivot irrigation project started. Here we can see the jump on the vegetation index between 2015 and 2016. In EarthMap, there are multiple climatic data sources available. Amongst them, we can view the Precipitation Layer. Once the central province in Papua New Guinea is selected, we can generate zonal statistics with the precipitation per year or per month from 1979 to 2019. Monthly average precipitations for the province in the selected period can also be shown. The same type of analysis can be performed anywhere in the world. Here, for instance, with temperature. We can see the changes in mean temperature for the district of Mayoni in Tanzania. This data can be downloaded as CSV and further analyzed. And with this, Thank you for your attention, and please visit earthmap.org.